Definition: a critical number of a function f is a number c in the domain of f such that either f prime of c equal to 0 or f prime of c does not exist. We want to find the critical number for the function f of x. In problem example 7, we will first take the derivative and we will use the product rule. So we take the g prime, so that will give us -1 plus function g again 4 minus x multiply f prime is 3 over 5 times x to the 3 over 5 minus 1. We simplify this a little bit. So first of all, we will make x positive for the exponent, because 3 over 5 minus 1 give us -2 over 5. So we need to move it down to make it positive. And then simplify this a little bit more. We will multiply the LCD. The LCD is 5 times x 2 over 5. 5 times x 2 over 5. So we want to combine this. So 5 times x 2 over 5. Then we will have 5 times -1 is -5x. We add the exponent. 3 over 5 add 3 over 5 is 5 over 5. So that gives us 1. Distribute for the second parenthesis. So we have 12 minus 3x. So we will have 12 minus 8x divided by 5, 2 over 5. Now follow definition. We want to find the critical number. So we have to set f of x prime equal to 0, or we have to find the value of x that make f of x prime does not exist. So f of x prime, f prime of x equal to 0 when we have 12 minus 8x equal to 0. So we solve for this and we will get x equal 3 over 2. And then the f of x prime does not exist when the bottom x2 over 5 for 5 multiply equal to 0. That means that x have to be 0. So we have the two critical number, 3 over 2 and 0. In terms of critical number, the Format theorem can be phrased as follow. So let's go back to the Format theorem a little bit. So now let's look at the Format theorem and this definition. So we have that f has a local maximum or minimum if f prime of x exists, and f prime of c exists, and then f prime of c equal to 0. In the bottom, it says that the critical number, to find critical number, so we should have f prime of c equal to 0 or does not exist. So I will take this part, f prime of c equal to 0 and f prime of c equal to 0. So combine this and that, what can we say is that the local maximum or minimum at c, if f has a local minimum or maximum at c, then c must be the critical number. So critical means maximum or minimum means critical number. So we have the bottom line is say that if f has a local maximum or minimum at c, then c is a critical number of the function f.